today's class starts, we are probably going to do a recap so that we'll be sure that nobody is lost. Maybe can do a quick recap or Q&A series, where uh people get to answer some questions to be sure to be following. So Ocha, you can go ahead.
All right. Good evening, everyone, and welcome to today's class. Hope you have all been doing good. Okay. So before we go into today's what we have to cover for today, I would like to know if any of us have any questions from our previous classes. Okay. Yeah. Please go on.
Good evening. Can you hear me?
Yeah, I can hear you. Good evening.
All right, so I have one question about Starknet DevNet. I don't know where is it that the account address we have to get a new address whenever we want to use Starknet DevNet.
Oh, okay. I've not used DevNet like that, but it's just basically running the blockchain on your local environment. So what address are you talking about, to be specific?
The private key and address that okay.
Okay, I think when you run it, it automatically gives you a couple of addresses and private keys, right? Are you there?
Yeah, yes, the
Oh, yeah. I think that's that. Then you can use the addresses and private keys to in your code, maybe for testing and stuff like that. Is that what you're asking?
yeah, I thought we use it to add an account on SNCast. And
Um,
I tried that and I could not use the private key again when I tried it some other time.
okay. When you tried it the first time, did it work?
Yes, it is.
Oh, okay. I've actually not tried that, so I can't give you an answer at the moment. But why don't maybe in the next class or so after this class I'll try it and get back to you.
Definitely. Thank you.
I mostly use Sepolia. I've not really worked with DevNets like that. So, yeah, but I'll look at it and get back to you. Okay. Does anyone have any more question? Okay, so we are all good from the previous classes, right? Okay. Let's go into what we have today. Today we'll be learning how to test components. We'll be testing the components we created from class 1, which is the ownership component. Let me share my screen real quick. I think I'll just share my entire screen. Okay, can we see my screen? Okay, yes. So In our first class, we created an ownable component, which basically manages ownership, functionality, features on a smart contract. So we are going to be writing tests for this component. So, yeah, we're going to be writing tests for this component, and there are two ways to do this. The first way is by deploying a mock contract. But in our case, we don't need to deploy a mock contract anymore because we already have a contract for it. So we are going to be deploying this contract where we embedded the component in, and we can use the contract to test the component. Another way to do it is by using the component states. It's more lightweight than deploying a mock contract, but usually use that when you want to test just the internal functions of the component. So let's begin. Let's see how we can start writing tests. First of all, I'm going to create a test folder. Should it be? It be in the extension. Okay, let me find coming here. So I'm going to create nope, not there. I'm going to create a lib.cairo file so that our test can resolve as well. Yeah. I'm going to go ahead and create a file for the test. Let's name it enable complete test on test enable. Now we need to declare it in lib.cairo. Okay. So we are going to be using Starknet Foundry, which comes with SN Forge. It comes with two libraries, SN Forge and SNCast. SNCast is what we use to deploy our contracts, and SN Forge is what we use to test. So to do that, we need to add it as a dependency in our scarb.toml file. I already did that here, and it's usually added as a development dependency. And this is how you do it. SN Forge std, then you specify the GitHub link and the tag. The tag is corresponds to the version you want to use. In this case, we are using the latest version, which is 0.31.0. So we need to import a couple of. Okay, someone is raising a hand. Oluwafemi, please go ahead.
I think your screen is frozen.
Oh, is it? Okay, let me stop. What screen are you seeing?
I'm seeing enable counter.cairo.
Okay, let me stop sharing and start again.
I think I can see your screen. I can actually see your screen.
Just give me a minute, please, guys. Can you see my screen now?
Yeah, I can.
Okay, so let me make it bigger. Is it legible enough? Okay, so as I was saying, we are going to be using SNForge to test our component, which it comes with the Starknet Foundry package. And to do that, we need to include it in our Scarb.toml file as a dev dependency. And this is how it is done on line 12. This name usually doesn't mean anything. You can give it anything you want, but it's just a common practice to name it SNForge underscore STD. And the GitHub link to the repository, GitHub repository, and the tag. The tag corresponds to the version you want to use, which in this case we are using the latest version 0.31.0. After doing that, we can go ahead inside our test file. We can bring in the SNForge, bring in some functions from SNForge underscore STD. So it should be reload. Okay, let me just grab it from the documentation. This is what we need. So we are importing the clear function, which is used to declare the smart contract. It returns the class hash, and can then use the class hash to deploy. And these traits are just the traits that would allow us use the declare function. So let's go ahead and deploy our only counter contract. So we are going to create a function for that. We'll call the function, let's call it underscore setup. Right, yeah. So now we want to declare our enable counter contract. So we are going to say let enable counter. This is going to be a class hash, so we can just call it class hash is equal to declare double quotes. Let's go to enable counter. This is the name we want to use. Dot wrap. I have no idea why this Scarb is not resolving. Close it and I can take it. Thinking it's really this to test this. Okay, yeah, the folder was supposed to be test. This supposed to be test. This. Yeah. Okay. Yeah, I'll fix that now. Dots. Yeah, contract class. In previous versions of SNForge, we didn't need to call contract class, but apparently in the latest version, some changes have been made and we need to call contract class on .unwrap. So it's a good thing to always refer to the documentations from time to time frequently, because things are always changing. Developers are always releasing new updates. So it's always good to keep up to date with the latest documentation. So after declaring the class hash, let's first of all confirm that in our enable counter contract here, if you notice, we are passing this argument as into our constructor. So when deploying the contract, we also need to pass in this argument. So let's create a constant for our owner. Const owner. It's going to be of type felt252. Let's just call it owner. Yeah. So now we need to create an array for our constructor called data. Let's call this call data. Equals to, we are going to use the array treat to be calling new. Yeah. This is supposed to be array of felt252. Yeah. Okay. So I just created an array to hold our call data, and we are going to be serializing the owner variable into this call data, then passing it into the deploy function. So what essentially this is doing is, it's this command here, or this statement here, is returning a new array, a new instance of an array, and it's assigning it to call data. And one important thing, this needs to be mutable for us to append serialized data into it. Now we're going to say owner dot serialize. We're going to pass in a reference of call data. Yeah. So having done that, now we can deploy our enable counter contract using the class hash. We can say let this returns into open contract. That's to get the contract address of the contract. We don't need the second parameter variable, so we just use an underscore there. Say enable counter /# dot deploy, and we need to pass in the call data as a snapshot. We're going to pass in at all data. To wrap is called. Let me confirm it from the documentation. Okay, just on wrap. Yep. Okay, just on wrap. Yeah. Okay. So now we have the contract address and we need to return it from this function. Contract address. We need to specify a return value here. Contract. So I need to import this from Starknet as well. Use are we following? Are we following, guys? Does anyone have any questions? Any questions? Please, if you have any questions, feel free to draw my attention. Okay. So now we have successfully created a setup function for our contract. So now anytime we call this function, it will deploy our enable counter contract and return the contract address. So we can start writing tests for our components. To do that, we need to decorate it with the test attribute. Let's just test let's call this test initializer, just to be sure everything is working. We're going to say let enable counter contract equals to underscore setup. We have this now. Now, because this is a contract, we need to use the dispatcher pattern in order to interact with this contract. Remember last class, someone asked a question about dispatchers and how they work. So we are going to be using dispatchers here to test the contract. So we need the dispatcher for the define an interface for this. I didn't define an interface. I only define an interface for the component. Right. Okay, so first of all, let's define an interface for our enable counter contract. So we'll need to make some modifications to this contract for the dispatcher for it to work. So we're going to say Starknet. Let's call this enable counter. This is going to be generic over T contract. Okay. So we have only one function here, which is increase count. So let's define an interface for that. This is going to be C contract state. We need an implementation now that we have an interface. We're going to be implementing enable counter implementation of to bring this into this context. Yeah. Use enable counter. Of type contracts state. Let's move this into, yeah. So now we have an implementation. So now we can use the dispatcher pattern, because this trait now is going, the interface we defined is going to expose a dispatcher for us to use. So we can go ahead and import it into our test file. Use, what's the name of our package? Intro to components. Enable counter. I enable counter dispatcher, and we need to also import the dispatcher to it. Yeah. Okay, I need to make this visible here. I should fix that. Yeah. Okay. So I can create a dispatcher now for our contract using the contract address. Let's say let enable counter dispatcher equals to this, and I need to pass in the contract address. Yes. Yeah. Are we following, guys? Any questions? Okay, that's good. So what are we testing here? We are testing the initializer. So let's test to confirm that the owner is equals to this owner and it's not equals to something else. So we can select owner equals to this dot special. Let's see returning. This person. This is supposed to expose. It's exposing only increased counts. That's strange. Let me comment this up. Let's go back to our contracts. Yeah, I get this. So this is exposing the increased count. It's supposed to expose. This company was born. Oh, okay. I think I need to import a dispatcher for the component as well. Use control. Dispatcher. Right. It's not visible, so you need to make it visible. It is public as well. Okay. Let me create another to dispatcher this time around. Okay. Oh, yeah. Okay, this is the function I want to call. Yep. So we want to assert now that this owner is equals to this owner, but we need to typecast this variable, this owner constant, into a contract address. Yes, so do that by try into that. If that fails, we want to output a message saying invalid owner. So we have created our first test. Now we can go ahead and test it and run test. First of all, I'm going to, before we do that, I'm going to add a script here. Let's test. SM for test. Okay. Now I can run Scarb test. So how to install. Should this be scripts? Oh yeah, I thought like I omitted the S. Yeah, it's the compiling. Okay, let's give you some time to compile. Okay. Okay, so our test is failing. Okay, let me check I think I'm using an incompatible version. Oh, let me check my version. Starknet. Okay. Yes. Okay. Okay. So our first test is passing now, and we are sure that the owner we pass into the constructor is correct. So now we can go ahead and test other functions. So let's look at our ownable component and see what functions we can test. We have tested the owner. Now we have a function for, excuse me. Okay, we have a function for transferring ownership. So let's see how we can test this function. Let's go back to our test file. Let's create another test. Test function test transfer ownership. Okay. So we need to deploy our contract again, and we also need the dispatcher. So I'm going to grab this real quick and paste it in. So now we want to call this transfer ownership function, and this function has an assert that checks if the caller of this function is the owner. So when writing tests, there's a way to trick the smart contract or the test to. You can set the caller to any address you want, and to do that, we are going to be importing the start cheat. It's called the cheat code. Start cheats caller address, and we also need the stop cheats caller address. So now we are going to cheat the contract by calling start cheat caller address with the owner, because this is the rightful owner. And we're going to say try. We need to typecast it into a contract address because it expects a contract address. And wrap. Okay, we need to pass in the contract address as well. Yeah. So now, whenever we call any function on the component, the caller will be set to this address here. So now we can go ahead and call our transfer ownership, but we need another variable to hold. Let's call this Bob 252. So now we want to transfer the ownership of the contract to Bob. How are we going to do that? We're going to come here and enable dispatcher dot transfer ownership. And what does transfer ownership take in? Transfer ownership takes in the new owner as an argument. So we'll pass in new owner, which we want to be Bob. We also need to typecast it on app. Now we want to assert that the new owner is Bob, because after this function is run, the new owner should be Bob. So we can just grab this one here. I'll just grab this real quick. Paste it in here and change this to we also need to get the owner as well. Okay, so we are finished writing our test, and it's always good practice to call stop cheat caller address after you finish executing the function you want. With this, you just pass in the address of the contract you are cheating. That should be it. We can come here and run our test again. Okay, good. Our test is passing, which means our transfer ownership function is working as we expect it to be. We can move ahead to the next function, which is renounce ownership. But before we move to that, does anyone have any questions? Are we following so far? Any questions, guys? Okay, nice. Okay, let's write test for renounce ownership function, which essentially transfers the ownership of the function to address 0. Usually address 0 on the blockchain has no owner. Anything that belongs to address 0 basically can't be accessed anymore. So by renouncing ownership, we're essentially transferring the ownership of the contract to address 0, which means no one owns the contract anymore. So let's test that. Function tests. Let's renounce ownership. Okay, so we omitted the function keyword. With this. Let's check how. Yeah, okay. We are also asserting here, so we need to check the. Yeah, we are asserting that only the owner of the contract can renounce the ownership. So we need to cheat the contract address. So we are going to copy this as well. Now we can call renounce ownership. Now we can assert that owner of the, I need to call this, let's grab all this. We need to assert that the owner is equals to, let's grab our address 0. And we think we need to import the trait as well. Get the trait. I don't think we need this portrait. Yeah. Let's change this to, let's see, ownership of renounce. Let's get the spelling. Ownership not enough. This will not test it. Okay. So all our tests are passing so far, which means our contract is working just the way we want it to work. Now, we have essentially root test for just one side of things on the contract, which is just confirming that all our functions are working. But usually we want to cover all edge cases. There could be loopholes in our component. Let's say we are testing now, and yeah, transfer ownership is working, but there could be a way a hacker can, a malicious actor can use another contract to call our function and actually get it to work. So we actually need to test that whenever a person that calls this contract is not the owner, it reverts. We get this error here, zero address, this one. Okay, someone is asking a question. Who is raising their hand? Was someone raising their hand? Oh, okay, let's move on. So we need to write tests to assert that only the owner of this contract can call this function here. So it's going to be similar to the ones we have written so far, but just with a little difference. So the first one will be transfer ownership. We'll just copy this and come down here, paste it. Let's see, let's rename this to not owner. Yeah, and now on initial deployment, Bob is not the owner, so we want to use Bob to call the contract, and we want Bob to transfer the ownership to owner. This is essentially what we need to do. This should fail, so we don't need this one anymore. Yeah, we don't need this one anymore. So let's go to the documentation. I need to grab should panic example. I said the corrector called should panic. Okay, yeah. So this is what I want. I want to get the panic message. So this function should panic with the error. What's the error we're supposed to get? Assert only owner. And what error does assert only owner throw? It throws zero address owner. So let's look at zero address owner, and yeah, this should be our panic message. So when we run test now, this test should panic with this message. If the test doesn't panic with this message, then it's not working as we want it to. So we can come here and run our test again. Okay, one is failing. Oh, we used the wrong panic. It should be caller not owner instead. Yeah, so you can see that we got the wrong panic message, so our test failed. It's the right thing should have been caller not owner. So you can just replace this and run our test again. Okay, so all our tests are passing. So let's go back to our component again. We are also asserting here in our transfer ownership function that the address calling this function shouldn't be address 0. So we need to test for that as well. So let's do that. We'll copy this one again because it's similar. Yeah. Test for address 0. And we want it to be okay, 0, 0. With this, we will not need to typecast it anymore. Yeah, and we want our panic message to be owner cannot be address 0. Is it? Let me check. Let me double check. Transformation 0 address owner. Okay, this should be. Let me create another just for. This should be 0 address caller instead of owner. Just so take this. Put the error again. We want this to be our panic message. Yep, so we can run our tests. Okay, is this really? We are getting owner cannot be. Function are we calling again? We're calling transfer ownership. Let's check. So this is the use of test. You get to see where your code is vulnerable and fix it. Caller address cannot be 0. Yep, this should be 0. Oh, I forgot to update the internal function. Yeah, it should work. Okay, I need to assert. I need to change this as well. Oh, but this is going to cause the other test to fail as well. Okay, for now we can just use one. I think that should be. Let's just take this out. I think there's a better way to do this. So only in this way. Okay. We can change this to this as well. In our test, yeah, I think we are good to go. Yeah. So let's run our test again. Okay, all our tests passing, so that's good. So far, so good. Any question, guys? Are we following? Does anyone have any questions? Okay, please go ahead to Chukwu.
All right. Thank you so much for the class so far. My question is still on the test. I
Yeah.
don't really understand this start sheet, something like under the test.
Okay, start it
That
color
particular,
address.
yes,
This one.
like I can't get my head on that.
Okay, so what this function is doing is it's tricking the, for example, now if this contract is deployed right on the mainnet and you want to use, let's say, your Bravos wallet or your agent wallet to call this a function in this contract, the caller address will be the address of your Bravos wallet. You get? So now in a testing environment, you don't have a Bravos wallet, you don't have an agent wallet to test with. So this start cheat caller address is essentially setting the caller address to whatever address you want it to be. And how does it work? You pass in the contract you want to cheat, you want to use the cheat code on, and you pass in the address you want to use, which is the second argument. We are using it here. Now we want to call transfer ownership on this contract here. We want to call transfer ownership. But as of now, without using the cheat caller address, there's no caller. The contract won't know which address is calling it. So in order to test for the owner, we need to cheat the contract into calling. We need to cheat our test into calling the contract with this address here, Bob, with whatever address we specify as the second argument. So now when I'm calling transfer ownership on this contract using the dispatcher, the caller address will be set to Bob. Are you following?
Yes.
Okay, that's basically the use of start cheat caller address, and stop cheat caller address is just basically used to stop the cheat code. So if I go ahead and call this one here, after stopping the cheat code, this test will fail. Okay, this test will still pass because we are using a panic message there. Let's call it on one that's not using the, yeah. So let's call it down here. Now that we have stopped the cheat code on line 45, you would see that the test would fail now. Okay, yeah. You can see our test on transfer ownership is failing with a panic message of caller not owner. The simple reason is because we stopped the cheat code on line 45. Now the test doesn't know who is calling the contract anymore. So it's going to fail because we have an assert statement in our contract that says only the owner should be able to call this contract. I don't know if you understand.
Yes.
Okay, very good. So let's undo that. Any more questions? Does anyone have any more questions? Okay, let's move ahead. I think with this, we have finished testing our transfer ownership function. Yeah, so we can do the same for renounce ownership. All right, so you can go into our this thing. Let's copy renounce ownership. Let's just call this field test renounce ownership field. Yep, we want to change this to Bob. Bob shouldn't be able to renounce ownership because he's not the owner of the contract. We can take this out because we don't need it. It won't get run anyway. And we need to include our panic message. What should be the panic message? Assert only owner. It should be caller not owner. Yeah. Okay. Yeah. Let's run our test again. Oh, it's going to fail. I omitted an R. But let's allow it finish and see. It should fail. Excuse me. Yeah, it failed because of the typo. So let's run it again to confirm that person. Okay, good. Our test is passing. So that's working as we want it to. Let's test for address 0, which should be the last test for our components. Let's call this 0. Address 0 shouldn't be able to renounce ownership to 0. 0. Yeah. So what should be the panic message? Okay, it should still be caller not owner. Yeah. Let's run our test again. Okay, it's failing. Let's see the reason why it's failing. Okay, it's panicking with caller cannot be address 0. Yeah, that should be correct. Let's look at our function again. So, okay, yeah. So it's failing on line 58, which is expected. We'll just change this to color cannot be address 0. And our test should pass. Okay, very good. All our tests are passing. So we finished writing tests for all functions on our component, but we also need to test it from our enable counter contract because we are using our components here, increase count, and we are asserting that only the owner should be able to call this function. So let's write test for that. Let's go back to our test file. And we're going to create a new test. Function test increase counts. And now we are going to use a different dispatcher. Instead of using the component dispatcher, we are going to use the contract dispatcher. Yes, this is the dispatcher we want to use in this case. And this should be contract dispatcher. Now we want to cheat the contract. So use address, our owner address. Yeah. So now we can go ahead and call increase counts. First of all, we want to assert that on deployment, our counter variable should be 0. So we want to first assert that. Let's get our count. Let's count equals to okay, I didn't create any function to get count, so let me create one real quick. Let's count. This will be a snapshot. Let's implement it here. Get counts. So self.count. Is it counter? Okay, yeah, counter. So whenever we call this function now, it should return, oh, this should return something. It should return 128. Yeah, because our counter variable is of count 1 to type 1 to 128. So specify that here. Let's take this out. Okay. So we can go back to you can see the use of writing tests. Now I didn't figure this out until I was writing tests for this contract. So that's one of the advantages of writing tests. You get to figure out what you left out in your contract and your vulnerabilities as well. So now we can call get counts and there's dispatcher, and it should return this coming from yeah. It should return this. Now we want to assert that count is equals to 0, or else we revert with a message of invalid counts. Okay, now that we have incremented count on line 121, you can get the count variable again, but this time around we want to assert that count is equals to 1, because what is our increase count doing? It's incrementing counter variable by 1. So this should be that. It should be that now. Let's stop the cheats. Passing the contract like this. Let's run our count again, our test again, rather. Okay, our test is passing, which means our test increase count function is working as we want it to be. But we need to write one more test again. We need to call it with an address that's not the owner of the contract and expect it to fail. So that should be our last test. Not owner. Yeah. Yes. You can change this to Bob. You can take these out because we don't need them. And read our panic message. Yes. Okay, so all our tests are passing, which means our contract is functioning just the way we want it to function. So that's basically it, guys. This is how you write a component embed it in a contract and test it. Although this is very basic, but it explains the fundamentals of how Cairo component works and how you can use them in a contract. So far, so good. Does anyone have any question? Not just from this class, it could be from our first class or our second class. Anything you want clarification on? No questions? Okay, so I'm going to go ahead and give you guys an assignment because Fridays are for assignment. The ownable component we created here is a very basic one. We just created it to explain the concept of components. But I'm going to need you guys to use the ownable component from OpenZebelin. Let me go there. Yeah, if you come to OpenZebelin and if you scroll to this on not accounts, access. Yep. This is the ownable component from OpenZebelin. You can see it has functions that ours didn't have. So we can use this component in our contracts. So we are going to, your assignment will be to bring this component into the token sale contract we created in our second class, and we are going to modify. Let me open it. Yep. So we created a token sale contract in our second class, and we used the ERC20 component from OpenZebelin. So your assignment will be to do the same for the ownable component and refactor these functions so that only the owner will be able to mint tokens. Do we understand the assignment? Okay.
Please, sorry, please recap one more time, please.
Okay, I said in our second class, we created this token sale contract, right? And we used the ERC20 token component from OpenZebelin. And we are using it to mint new tokens, right? But basically now, anybody, if this contract is deployed, anybody can call our mint function and mint new tokens, right, to themselves. But we don't want that to be the case anymore. We want to restrict the asset and the access of this function so that only the owner of this contract, which is the person that deployed the contract, we want to give only that person access to this mint function. So your assignment will be to bring in the ownable components from OpenZebelin, integrate it to this mint function so that that functionality is included in this function. Do you get it now?
Yes.
Okay. Yeah, so that's basically it, guys. Does anyone have any more questions? Okay, can I? Okay. I think I'll ask Kelvin. There should be a way to drop assignments in. Okay, this form is for submission. I'll ask Kelvin. Don't worry, I don't think writing it here would be the best option. I would ask Kelvin on how assignment is given, and yeah, I'll get back to you guys. Are we okay with that? Yeah, okay. So if we don't have any more questions, I guess we can call it a day here. Thank you guys for attending. It was a pleasure. Yeah. So good night, guys. I think this will be my last class, but if you have any more classes, then I'll see you guys in that class. All right. Good night. And I will push the changes we made today, and I'll push it to the GitHub and also share the link with Kelvin so I can share it with you guys. All right. Good night, guys.